Hi, my name is Travis with Kaiser, and this is our How Not to Save Energy presentation. Try to get this done hopefully in about 20 minutes of talking. So the background on this is really that planning and design, my department is now tracking the energy impact of major energy affecting projects. We're doing that tracking in eBuilder. So anytime there's a project like an air handler, boiler, chiller, lighting, etc., we look at the pre-project energy and the post-project energy. We really started this in 2023. So most of what we're looking at now are the projects that were completed in 2021 and 2022. But we actually file a report per project, and we file it in the project folder in eBuilder, looking at pre and post energy for that particular building. How do I do next slide? Okay, so this slide shows the projects, or I should say the buildings, that have energy savings. KBTU is in the column on the far right, and sometimes the energy savings is significant. Sometimes it's quite a bit. One thing to point out that you'd notice almost immediately is that the energy is rather independent of the spend. You can sort of get a sense of that here. We have some projects that spend quite a lot and they show not much energy savings at all. We have some projects that spend not much and show some very impressive energy savings. Mostly I would say that spend and savings are just not correlated. There's not a direct relationship between those two variables. And you can kind of see that on if you take the BTU divided by the cost, or sorry, the other way around, the cost divided by the BTU of savings, you can kind of see that the numbers are really all over the board. So not a real clean relationship there. Then this slide shows the projects with no savings. And we found quite a few projects that have no savings. Or I should say buildings that have no savings. And this is sorted by spend of the project. We've had some projects at the top of the list that spend quite a bit, and from an energy perspective, those buildings are unimproved. And so the three that are circled here are the case studies that I'm going to run through here in the next few minutes. So first case study is this Meridian MOB boiler project. So this project is a $635,000 project. That was the budget. It actually spent $535,000. You can kind of see the schedule down there. Construction period was about 4 months, from December to March. And what we do here, the way we look at building energy is to look at pre-project energy and then post-project energy. And we actually exclude the construction period from that assessment. So in this case, the construction was about a 4-month period. We pull that out of the energy assessment. So to start off with, the OPR on this project had some good things in it. There's a reference to Title 24, there's a commissioning requirement, and there's a line in there about these dual boiler variable primary systems, which means that somebody writing this OPR was thinking about an energy efficient system. On the downside though, in hindsight, there was no actual energy goal here. So there's no percent goal, no numeric goal, nothing to track against in terms of was this project or not successful or not in terms of saving energy. This is hindsight. This analysis was not done during design. This is an analysis that we did in hindsight, but we can actually look back at the pre-construction period for this building, and we can see pretty clearly that this building is a gross energy user. In particular, this building is a gross thermal energy user. Within Kaiser, we have some benchmarks and existing energy benchmarks, and this building was well over those, 3 times the heating energy benchmark before design even started. Now the design team didn't know that, and that's kind of important to what you're going to see here in the results. They didn't actually know that they were working in an energy hog building. So the BOD, when it comes to the BOD had some good things in it. We had 4 options and we had a life cycle cost. So that's pretty good. That's normally what we would expect to see in a BOD. In retrospect though, those 4 options were really just 4 different boilers. So it's like 4 different model numbers or manufacturers. So none of the options was actually substantially different from the other options, just minor tweaks really. And the energy models that were presented and put into the life cycle cost analysis, they weren't accurate. They weren't near the pre-design energy signature. And they also didn't show much difference between each other. You know, there's only less than 10% variance from option 1 to option 2 to option 3, etc. And most importantly, the design team never got in there and tried to address any of the root causes of the high energy use. From what I said before on the last slide, they didn't actually know that they were sitting in a building with high energy use, so they didn't go and look at any of those causes. In the commissioning plan included some good stuff. The diagram on the left here shows an acceptance criteria, which was in the basis of design. It was in the specifications. It was in the commissioning plan. It said that we should accept the system when we saw some good turn down on the boiler system. Once we got to commissioning, we failed this criteria very clearly. And unfortunately, our commissioning agent endorsed the project as complete. They wrote a report that said, hey, this is fine. We should accept the project. We could call that a foul on the commissioning agent, but in all fairness, this was a design error. There was nothing in the design that would have made that chart on the left ever come true. There was no portion of the design that actually designed for that. It was just sort of a criteria without any basis behind it. And so we did fail it, and we should have failed it, right? And this is our final energy comparison on the building. This one is very, very close. So we did a weather-corrected comparison. We can actually do that. We correct the pre-project period and the post-project period for the weather data that happens in that period, but still in this case the variance was less than 1%. I'm talking fast here because I want to get through multiple case studies, but here's some of the lessons learned here. We didn't have an energy goal here in a very real sense, and when we got into design, our design team did not look at historical data. As a result, the energy options that they considered weren't very meaningful. They didn't do any root cause assessments. There were a number of things that happened that were sort of suboptimal during design that are details. And then, of course, the commissioning reported success here, which is probably not correct on the part of the commissioning agent because we didn't actually succeed with the energy criteria, at least. And so, a number of things that are lessons learned here. Next case study is an Elk Grove MOB boiler project. This is another boiler project. This project had a budget of $544,000. They actually spent $414,000. March, April, May, June, July, September. So a little bit longer of a construction schedule here, about 6 months. And to jump right into the basis of design here, this basis of design has a little bit less. There's one reference on there that says to meet current energy standards, and that's kind of about all we get in terms of the mention of energy in the OPR. So no numeric goal, nothing like that. On this project, we did not have a basis of design. They never filed a basis of design. There was no review of the basis of design. This project also didn't do a commissioning plan. They didn't do a commissioning report. There's no commissioning on the project. And so obviously no numeric energy goals. So this is really just kind of a replacing kind project. We can look at the pre-project energy. There's the pre-project period, a little bit longer of a construction period, and post-project energy. And in this case, the usage is actually up by 17%. So this again is weather corrected. This one probably didn't need to be weather corrected data, but in this case, replacing kind project. No real design considerations of energy, no project goals in terms of energy, no commissioning whatsoever, and so we actually see that energy use has increased. And those are the lessons learned, right? We didn't have any effective energy goals. We didn't look at historical energy data, didn't really look at any options. There was really no design to speak of, aside from the replacing kind design, and then there was no commissioning. So last, another boiler project, last case study is this Embarcadero MOB boiler project. And so in this case, this is a much larger spend, right? This project budget is $6.1 million, and we spent $5.9 million of that. It had a significant construction schedule, so this was going on for quite some time. Now, in terms of energy, the Embarcadero Medical Office Building is part of the Fremont Energy Campus, and so it doesn't have its own meter. Even the natural gas meter, it's part of the overall natural gas meter of the hospital, right? This MOB is 42,000 square feet. The campus is 373,000 square feet. So the natural gas to this facility, at best, is 11% of what's happening on the meter. If we were to save 50% natural gas at this project with the boiler replacement, then that would only be 5% on the overall meter. There's almost no way that we would be able to see that on energy metering. And of course, that's exactly what happened. Pre-project construction period, very long construction period, and post-project construction period. We have energy for both of those periods, but this is energy for the whole hospital. It's not energy for the Embarcadero MOB. This was a pure remove and replace owner's project requirements. That's all it was. Just it says remove and replace. There's no reference to energy, not even any reference to efficiency of the boiler itself. The basis, there is a basis of design on this. They did submit a basis of design, but there's no energy considerations. There's really a lot of opportunities missed here, right? This is a hospital. It's a very high EUI building. So there was a lot of things that could have been looked at during design, and we just didn't look at them during design. There was a commissioning plan on this project, actually a very lengthy commissioning plan, and this one is a great one to look at in terms of lessons learned, because there were a whole set of acceptance criteria on this commissioning plan. You can kind of see them. Unfortunately, my face is over with them in this recording, but there's a whole list of acceptance criteria there. There were 12 items that we checked during commissioning to make sure that this project was acceptable at the end. They went through quite a process. Unfortunately, none of those had anything to do with energy. None of those had anything to do with efficiency or run times or anything like that. And so again, in the commissioning report, we get a commissioning report that says, hey, this thing passed all the acceptance criteria, and it did. They're not lying. It did pass all the acceptance criteria, but none of that had anything to do with any energy metrics or anything like that. And of course, the final energy on this, we did see a 7.9% increase at the hospital, but honestly, there's no evidence that that's related to the project at all. The project had to do with this 10% portion at the MOB. We're seeing some changes on the meters, but there's no way that we can say that that's related. So again, lessons learned on this one. There's no actual energy goals in there. We didn't look at historical utility data during design. We didn't really have any options that were considered that would have had an effect on design. No energy considerations during design. This project also was in an unmeasurable scenario. So if we did have energy considerations during design, we should have or would have needed to add some way of validating those. And of course, during commissioning, there was no energy validations that are worth talking about here. So what kind of conclusions can we draw from these how not to save energy projects? So the first thing that I think we've been saying all along is that replacing kind projects, particularly if there's no design, no commissioning, that's very unlikely to produce any kind of energy savings. At best, it's going to be a one-for-one change out that gives you one-for-one results. And what we've seen is that very often, putting in new things that consume natural gas better, you can see energy go up. So during the goals and alignment phase, what we're trying to look at now is to actually set energy goals with the projects and make those energy goals numeric. Always make those goals with full awareness of the historical utility data, right? When we have historical utility data, always look at that and then make sure that those results will be measurable. That last case study that I showed you, even if we would have had an energy goal, we would have had to add a gas meter at that MOB in order to make the results measurable. When we do consider options, we need to look at the systems that we're in. So it's not just a matter of, hey, let's look at this boiler or let's look at this air handler. We need to look at that boiler or that air handler as a function of the system that it sits in and consider that system functionality during assessments. And then there may be options that we can put on the project, sometimes inexpensive options that we can put on the project that address the system more holistically than just addressing a piece of equipment. During design, there are a lot of things that we need to do during design, right? We should specifically talk about what the operating hours are, what the shutdown hours are, the turn down hours are, what the temperatures are, the differentials, the flow rate, all of that design, those design details need to be complete for a good energy design. And then, of course, we do need to include, if we're going to do an energy measure that's not going to show up on the meter, then we need to include enough metering in the project to actually validate that we're getting it done. During commissioning, we need to have relevant test criteria. We should only report success when we actually achieve success. That's sometimes difficult. We've got to have enough metering and validation in place to validate the measures that we are the goals of the project. That should go without saying, but it does. So, what are we trying to do now? What we're trying to do now is look at project opportunity. This is a list of buildings that have HVAC and lighting projects going on. So a building on this list, say the Kaiser Sunnyside Medical Center up at the top there's $12 million worth of projects going on in that building that's in design right now. So those are lighting projects, HVAC projects, different types of projects. Those projects, with that amount of spend at that building, I think stands to reason we should be able to affect the energy performance of that building while we're doing that much. And so the idea here would be any time that we're spending more than $1 million or $2 million in a building, that we should set some clear energy goals and then follow those energy goals through with the projects. In my ideal world, those energy goals would be numeric, and they would be literally stated in the OPR. This is an example that we recently worked on with a project manager, where we came up with an estimate of the savings that's available, and then literally put the number right into the OPR. Now, we've always said the OPR is a working document or a living document. So if the design team comes back and says, hey, that number is crazy, we can only do half of that, then we can change it in the OPR. Or maybe the design team comes back and says, hey, we can do much better than that, then we can change it in the OPR. But at least we would have a number there and have that number carry through the project towards the validation phase. And then, of course, during options, within the OPRs, we're calling out that system functionality assessment, and we're calling out to try to look at options that are more than just the piece of equipment, and have a cognizance of the system that the piece of equipment is sitting in. I know most project managers, when they hear that, say, well, I don't have budget. I don't have enough budget to work on anything within the system. But oftentimes, the changes within the system and the changes that we're doing at the equipment can have trade-offs to each other. And so we want to look for things that are cost effective at that point in time, during design, during scoping. Within the design phase, there are a lot of things that we actually need to check during the design phase. Specifically, operating hours is a huge one. Hours per month is much more important than BTU per hour or watts per hour. And so if you're running a boiler system 24/7, you can have the most efficient boiler system on the planet. But if you're running it 24/7, then that's going to use a lot more energy than if you're running your boiler system 330 hours a month, right? And so we also need to validate temperatures and pressures and flow rates and size of the equipment for all of the ranges that it's actually going to see during operation. And then in commissioning, we want to use the data. We want to validate the measures. We do want to validate all the energy measures and not skip energy measures. And then it's hard, but not declare success on commissioning if those energy measures aren't in fact successful. And so that's going to require a lot of conversation. The commissioning checklist that you're looking at here is for a new hospital. And there were a lot of energy measures in the design of that hospital. You know, something like 300 energy measures stated within the design, and there's a lot of them that are currently unsuccessful. And so it takes a lot of time and a lot of programming and a lot of sort of diligence to really get each one of those things at an optimal range before turning it over to operations and calling it successful. So I think that's what we have. That's the presentation, how not to save energy. Hopefully, though, it's a presentation that talks a lot more about what we can do within projects, learning lessons from the ones that didn't necessarily do so well. That's all I've got. Thanks.